game called The Detective Wizard. It is a word-based game in which the player is a detective attempting to solve a murder at a high-class hotel.
So there are three different layers to one of these programs, and the first layer is the model layer, and the model layer holds all of the information concerning the game and is created from the classes, which are a collection of objects that share similar attributes.
The next layer is the control layer. The control layer contains all of the algorithms concerning how the game is to run. It also acts as a way of communication between the first layer, the model layer, and the last layer, the view layer.
The third layer is the view layer, and it's what the player sees and interacts with, and it contains like the menus and requests the player's input and provides an output according to the inputs.
Okay. An attribute is a characteristic of an object.
And a method is a series of statements that are grouped together to perform an action.
A class is a group of objects that share similar attributes.
So I'm just going to show you an example of what an object instance is. Quickly, I'm going to try. No. So right here is an example of an object instance, and this calls the main menu view.java file, and the main menu is the name of the method, and new is creating the instance of the object main menu view.
All right. So the methods and attributes of the model layer are. I'm so sorry. So starting with the end user, the attributes are the name, role, and score. The methods for those attributes are the getters and setters. So for example, get name, get role, set role, get score, and set score. And the end user is associated with other classes such as the game. And association means that it has the end user has the ability to be in a game, and then also the game has the ability to have an end user.
So for this second class, it has all these getters and setters, and I'm going to talk about the character. And the character in this situation right here only has a name and a role. So there's two attributes, the name and the role, and the character has an association with the rumor, the game, and the scene. And the association with the game is that it has all the characters, and the characters can only be in one game. The relationship between the game and the number of characters is called the cardinality. Another method that is used is the setter, and the setter takes the information that the getter retrieves and it stores it.
Next, we have the UML for the control layer. In the control layer, as you can see, the program control is dependent on several other classes, such as the end user, game, and map class. What this means is that the program control uses data from those three classes.
Here I'll show you the control layer one again. So some control classes share a dependency. For example, the player control right here in the middle is also dependent on the end user class, the game class, and the math class. In addition, the player control is also dependent on the inventory item class over here, and the clue class, and the rumor class, and the scene class. They all have a dependency on those.
Next, there are 3 necessary steps to turn the classes into a Java bean. First of all, you need to implement the serializable interface. And what that does is it allows the data stored in the class instance to be translated into a format so that it's able to be stored on a disk or sent across the network. The second is to create a default constructor function for the class. This constructor is used to create a new object instance for the class. The constructors that we'll be using are default constructors. And thirdly, all class instance variables should have private modifiers and public getter and setter functions. Alright, so in this class, which is the player class, it shows the implementation of the serializable, wow. And then we also have our generic public setter, or constructor, followed by our getters and our setters.
So, just as another example of switching a class into a Java bean is on my own code. And it's the exact same as she had just mentioned. This is where it implements the serializable. This is to create the new object instance, and as she mentioned, the new object instance has no input parameter, and so there's nothing in there. And then down here it has the getter and it has the setter. That's all, a public void or a public string, and like she had mentioned.
Alright, next we have, it stopped working. There it goes. Alright, next we have, in our player class, we have our different variables that we've created, and those are here. We've set them up as the name, role, score, and we've actually made an addition to ours to have the number of clues. And these variables have their scope is throughout the entire project because they are created in the model layer, which makes their lifespan continuous throughout the project.
Okay, so I just have another example of the lifespan and the scope. And so in this example, it's in the game menu view, and the variable menu right here is contained inside the view layer, and the scope is contained only in that class. And it's sorry. Its lifespan lasts as long as that class is called, and since it's called through the entire thing, that's how, or however long it's lasts, that's how long its lifespan is. So
All right, and then we have how arguments are passed between each function. So what we have here is an example of one of the equations that we used. The parameters that are set here are calling the variable or the attribute from the model layer into the calculation so that we can use it to create the function for the game.
So this is just another example, again, of an equation that we are using and the parameters that are used in it. So this is a different equation, the calculate killer hint, or calc killer hint. And so the parameters are obviously in here, like she said. So the killer height and the character height and the distance. And so that just are the parameters. Those are just the parameters of that other separate equation, which is more or less the same thing that she just explained. It's just a separate equation.
All right. Next, we have there are several different mathematical and relation operators that that you use throughout Java. First, you have like addition and subtraction, and then you also have these two vertical bars, and what that means is or and or. So for example, this reads the necessary item is greater than -1, and it's also less than 7. And then in a previous one, we also have the exclamation point and equals. And what that means is at least for this instance, it means that the killer height is not equal to 6.7.
So I'm just going to show you more of the operators that can be used in a calculation, or an equation is a better word to use. So here, back into the equation that we were doing, like she said, she pointed out these two vertical bars that just mean or and. Here is less than or equal to. So whether the character height here is less than or equal to 0. Also, just here, this little star represents multiplying, and so that in this case it would be the killer height times multiplied by -1. And right here, this little slash is just division, and so this whole thing would be killer height times or multiplied by -1 divided by distance. And then again you see this, and you see a lot more of the ands and the less than or equal to, or in this case right here, more than or equal to 7. And you can see here it has a double answer, and a double is a numerical value that can contain a decimal value. So those are just more examples of operators that you can use in equations.
All right. There are a few types of if statements. There's an if then else, and an if then else ladder. An if statement or an if then statement states that if these parameters are met, then this will happen. An if then else statement states that if these parameters are met, then this will happen, or this will happen, or else this will happen. An if then else ladder is a series of if then statements followed by an else statement. An example of a if then or an if then else statement is here inside the notebook view. So what this shows is if these parameters are met, then the system will print out this menu, else it will print out this menu. And then once it's gone through the menus, what it'll do is it's going to jump down to our switch statement, which is here. Earlier in the code, the user is asked to input an alphabetical number, an alphabet. And what the switch statement does is it goes through and it says, okay, is it this number? If not, it moves on to the next one, and so on until it finds the correct one or outputs the error that is not part of the switch statement, or it's an invalid input.
And so, just like she was just showing, we have other switch statements or switch, things are really useful, and so we've used them a lot. And so, in this game menu view, we have one. No, never mind. I'm looking at the wrong one. But here, we'll look at the main menu. That one does definitely have one. See, it has this switch selection, and so like she said, it goes through each one and it finds one until it actually works, or else it just does this other thing. And sometimes it just automatically assumes that there's an else, and so in this situation it says if this, then continue to do this, just like it had said before. And there are lots of examples of if this, then return 3. And so that's just another place in another example where you can use switch statements or the if statement.
Alright, then we have our while statements and our do while statements. So what a while statement does is, for example, here in the notebook view, while or as long as the input is valid, it will go through while the statement or the input is not valid, it will prompt the player for a new input. It'll collect the input, and then it'll make sure the input's correct. If the input is invalid, it will jump back to the beginning of the while statement, and then if the input's valid, it'll break out of the while statement and go into the switch statement.
And so, like she was just explaining the whole while do thing, the while thing, the do while is basically the same thing, but it kind of does it in an opposite direction. So the do while evaluates its expression from the bottom of the loop instead of at the top. So like she was showing, while this, then do this. It basically just says do this, while this is this way. And so basically it just, like I said, it just evaluates expression from the bottom, because this is stated at the bottom, this while, but it does it first, or it states that first, instead of doing it at the top like just the normal while thing does.
All right, so next we have our different test matrices. Matrices, that's kind of a hard word. So so what the test matrix does is ours are set up for the equations, and what we've gone is we've looked at what the boundaries are, as you can see on the far right over here. It has our boundaries, or the limitations of our, like how many items you can contain, and a character value. And then we've created a invalid test scoring to test like the limits and make sure that our program was actually running within those boundaries. And then we've also put a test matrix or test examples to make sure that valid entries are still being processed. And so we've had a little bit of an issue with our test matrix. It is running, but it's actually showing it's running our game rather than running the test matrix. But this is kind of an example of what, this is an example of the code for the test matrix. So first we've put our variables that we're going to be running through the test. And then we've created the instance. And then we've created what we expect. And then created another instance where we pulled the calculation from our control layer. And then we check to make sure whether or not what we expected is what the result was. And yeah.
So I have another one of these test matrix, and so as you can see here, it just does like the same thing as she was saying. You know, it tests and says, you know, if this is the input of the killer height or the character height or the distance, then it would output, you know, what it would output. And so also, like she said, we're having a lot of trouble with the thing actually doing what we want it to do. But this is just another example in a different equation, a different test for a different equation. And it just, like she all said, you know, it goes through all of these different things, and it says with the necessary item, and it goes through all of the parameters like we had discussed, and it goes to the player control to do all of these things that she had explained, and it's supposed to go out. And I wish I could actually show you it working, because it should work and it has worked before, but it's just not working right now. But I think we're done, right?
Yeah, we're good. Thank you for watching.
Thank you. I hope you learned something.